Next, we'll try a few examples of simplifying radicals using the product property. The first thing you'll do is find the prime factorization of the radicand, the number under the sign. You can do that like we did at the beginning of the year with a factor tree. So for example, 50 could break down into 2 times 25. Remember that you circled the prime numbers and you continued to break down numbers that were not prime until you ended up with all prime factors. So the prime factorization of 50 is 2 times 5 times 5. So we're going to rewrite the square root of 50 as 2 times 5 times 5, which is 5 squared. So we're rewriting it in the prime factorization form. Now we're going to use our product property, which says we can split this up along these factors. So I'm splitting up the factors with the 2 and the 5 and putting those as like 2 separate mini problems. Now also remember, if there's no index on the radical, it's a square root. And recall that we said that a square root and a square are inverses. They undo each other. So the square root of 5 squared equals 5. The square root of 2 is just the square root of 2 because there's not 2 factors there. It's just a 2 to the first. Now, in terms of standard notation, we typically put the integer part first and the radical part second, and then you would read this final solution as 5 root 2, or 5 times the square root of 2. Let's try another one. Let's try the square root of 48. This time I'm not going to write out the factor tree. I'm going to try to do the prime factorization sort of like in my head. So the square root of 48, I know that that's even, so I can break that up into 2 times 24. And then 24 is 2 times 12. And then 12 is 2 times 6. And 6 is 2 times 3. So I could, rather than making a factor tree, I could think through it this way. And because this is a square root, I'm going to be looking for things that come in groups of 2. So I'm going to rewrite this as the square root of 2 squared times 2 squared times 3 to the first. Now, the only reason I didn't put all the 2's together into a 2 to the fourth is because it's just a little bit easier to see how these are going to end up being inverses when you leave them in groups of 2 rather than putting them into a group of 4. So next we'll use our product property, and we'll break this up into the square root of 2 squared times the square root of 2 squared times the square root of 3 to the first, which is just 3. Remember that a square root and a square are inverses and they undo each other. So the square root of 2 squared is 2. 2. Then we've got the root 3. And 2 times 2 is 4. So our final solution for this question would be 4 root 3. All right, and let's try one more here like this. The square root of 150. And again, we're going to start with that factor tree, or maybe using your calculator. 150 is even, and that would be 2 times 75. 75 is divisible by 3. That would be 3 times 25, and 25 is 5 times 5, or 5 squared. So now I can use my product property and make this into the square root of 2 times 3 times the square root of 5 squared. Now, the reason I didn't split up the 2 and the 3 is because neither of them are going to simplify. I don't have those inverse operations because I don't have 2 2's or 2 3's. So I'm going to leave those together. But the square root of 5 squared is just 5. And the square root of 2 times 3, I'm going to put those back together and put that as a root 6. And again, we usually like to have the integer part first and the radical part second. So the square root of 150 simplifies to 5 root 6.